All right, let's dive into something that really flips a classic sci-fi idea on its head. We're going to look at some research that takes one of our biggest fears about space and asks if it could actually be a source of life. For as long as we've been thinking about space travel, radiation has been this huge, scary monster. It's always been seen as a total deal breaker for life, right? A constant, deadly threat to our astronauts and really any biology we can imagine. But what if we've only been looking at one side of the coin? What if that exact same lethal energy, under just the right circumstances, could actually be a life-giving force? And look, there's a very good reason we're so scared of it. This isn't just hype. Galactic cosmic rays, or GCRs for short, are these super high-energy particles. They're basically the leftovers from ancient supernovas, and they're zipping through the galaxy at almost the speed of light. Here on Earth, our atmosphere and magnetic field protect us, but out in deep space, yeah, they are a massive, massive problem for any long-term human mission. I mean, when this kind of radiation hits a living thing, it is just brutal. It's like a microscopic demolition crew. It tears through DNA, wrecks important molecules, and causes a whole laundry list of terrible health problems. Cancer, heart issues, even damage to the central nervous system. So let's be super clear. For complex life, like us, this stuff is an absolute killer. No question about it. Okay, but now let's totally shift our perspective. Forget about a human body for a second. What happens if that same cosmic ray doesn't hit a person, but instead hits a simple molecule of water, one that's buried deep under miles of ice or rock? Well, that brings us to this key idea, water radiology. Now, that sounds super technical, I know, but the concept is actually pretty simple. It just means radiation splitting water apart. Seriously, that's it. Think of a cosmic ray like a tiny, invisible bullet. When it smashes into a water molecule, it just shatters it into a bunch of new, highly reactive pieces. So, here's how it starts. It happens in just a flash. That cosmic ray doesn't just bump into the water molecule. No, it slams into it with so much force that it actually knocks an electron loose. This creates a really unstable, super energized version of that water molecule. And this is the result. That one little impact kicks off a whole chemical chain reaction. What you're left with is this chemical soup of brand new molecules, and these things called radicals, which are basically just super reactive fragments that are desperate to bond with anything they can find. And here is the absolute kicker. Some of the stuff this process creates, things like hydrogen gas and hydrogen peroxide, turns out to be the perfect food for certain kinds of microbes. It's like a chemical lunch buffet, providing pure energy with absolutely no sunlight needed. And hey, this isn't just some wild theory. It's happening right now, here on Earth. Miles deep in a South African gold mine, scientists found this amazing bacterium. It's called Desulphororudis oryx veictor, and it lives in total darkness, completely alone. And what does it eat? It powers itself using the byproducts of radiolysis from the naturally radioactive rocks around it. This is proof that life can use radiation as an energy source, even if it's indirect. So, if life can pull this off on Earth, you gotta ask, where else could this be happening? This one idea forces us to completely rethink what we mean by a habitable zone. And that's led scientists to come up with this awesome new concept, the radiologic habitable zone, or RHZ. This has nothing to do with being a certain distance from a star so you can have liquid water on the surface. Nope. This is about any place where you have enough radiation and enough water, usually hidden underground, to get this chemical engine started for life. And just like that, boom. The map of potential homes for life in our own solar system just got way, way bigger. All of a sudden, we're looking seriously at the deep subsurface of Mars. And even more exciting, we're talking about the huge liquid water oceans that we're pretty sure are hiding under the thick ice shells of moons like Jupiter's Europa and Saturn's Enceladus. Which brings us perfectly to one of the coolest missions flying through space right now, a mission that's actually going to check out this very idea. So, let me introduce you to JUICE, the Jupiter Icy Moons Explorer. It's a European Space Agency mission, and it is on an absolutely epic trip out to the Jupiter system with the specific goal of checking out those big, mysterious, ocean-bearing moons. And when I say epic, I mean it. Check out this timeline. This is an 8-year odyssey. JUICE is swinging by Earth, the Moon, and even Venus to get gravity assists, all just to get out to Jupiter by 2031. It's an incredible journey. But what it's going to do when it finally gets there, that's the really exciting part. JUICE has a jam-packed itinerary. It's going to study Ganymede, which has its own magnetic field. How cool is that? It'll check out Callisto's ancient cratered surface. But for our story, the star of the show is Europa. JUICE is equipped with a radar that for the very first time will be able to peer beneath that thick ice crust. It's going to hunt for pockets of liquid water, the exact places where this radiolysis process could be happening as we speak.
So what's the big takeaway here? I mean, what are we really looking at? Now, JUICE isn't designed to find little green microbes directly, but what it can do is find the evidence, the conditions, that would make a radiolytic habitable zone a real possibility.
And this chart just lays it out perfectly. For so long, we've had this one idea of what makes a world habitable. It needs sunlight, it needs to be on the surface, and it needs liquid water. But now we have a second, totally different path to life. One where the energy comes from cosmic radiation, where the location is deep underground, and where life can thrive in water that's buried under miles of ice. And that really just leaves us with this one mind-blowing question. If we start seeing radiation as not just a killer, but also a potential creator, how many places have we been ignoring? We're not just adding a few new candidates to the list of habitable worlds. We might be fundamentally underestimating how common life could be. Maybe, just maybe, the galaxy is full of life, not basking in the sunlight, but quietly thriving in the dark. Thanks for joining me.